Everyone, this is BC Polar Notes number 2. Okay, so you've gotten an opportunity to dabble with polar derivatives, right? But what does it all really mean? So this lesson is solely based on that. How do we interpret our answers? What do our answers tell us about the curve or the particle in this sense? Okay. So here's our FLT. Go ahead and copy it down. Press play whenever you're ready. So you want to be able to know what the information that you get tells you about the curve. Okay, so how do we interpret our answers? And we did a little bit of this back in Calculus AB, so it should look somewhat similar here. Okay, so over here is your common x and y axis, and then I introduce you a polar curve where, let me use a different color here, where this red segment here is kind of like your pole. Okay, so it kind of serves as like a third axis. Okay. So here are some things that you need to consider. Let's say that you had a point right here. Okay, a point A. So if I tell you, if I can tell you that this point is traveling to the left, okay, will it eventually hit the y-axis? Okay, so obviously if it travels left, it will hit the y-axis, right? So does that happen to all points on any coordinates, on any quadrants, right? So for instance, if you were on point B and you traveled left, well, you hit the y-axis. So in this case, if you're at point B and you travel left, you wouldn't hit the y-axis. Okay, you would have to actually travel right to hit the y-axis. And same thing here, if point A traveled towards the right, it wouldn't be hitting the y-axis either. Okay, another scenario. Let's say you're at point C and you're going upwards, right? You'll eventually hit the x-axis, right? But if you had a point here, point D, and you traveled upwards, will you hit the x-axis? Absolutely not, right? So here's my point. Is it enough to know what direction you're going in, right? To know where it's going to head. So what you want to think about is it takes two conditions. It takes two known facts to determine where it's going. It's not enough to just know the direction of your point. It's also important to know where it starts. Okay, so you want to know where it starts, the location, but also where it's heading. So if you can figure out those two pieces of information, you can tell where it's going here. Okay, so for instance, if you have a radius r, okay, and if r is traveling back, let me draw you some vectors here. If r is traveling this way, notice how it's heading back towards the origin, right? But if you have a point over here and is traveling in that same direction, is it guaranteed to hit the origin? Absolutely not, right? So again, you need to know where you are and where it's going. You need to know where you are and where you're going. Okay? And how do we know where we are, right? Where we are is basically our position, right? Our status. This is definitely where we are. Where we're going is in reference to the derivative. Okay, and I'll give you guys a little bit of a refresher on that, okay? So remember the concept of the implications, right? So we can tell that a function is increasing if its derivative is positive, right? Similarly, we know that a function is decreasing if and only if the derivative is negative. That was way back in AB. So this serves the same purpose here, okay? So for instance, we have three things going on here, and you guys are going to see three different examples of what happens with x, with y, and with r, okay? So all of these are your positions, okay? In some sense, you're going to get a location of your point. Now, take a look at their derivatives. dx over d, I think did they use theta? They did. Okay. There's the derivative of x with respect to theta. There's derivative of y with respect to theta. And there's the derivative of r with respect to theta. Okay? So, what you want to think about here. X is responsible for what two directions? Okay? When you think of the x-axis, you're thinking of the horizontal axis right here, right? So it can either travel left or right. So it works the same way. If your derivative happens to be positive, then you know your position is moving towards the right. Okay? If you know the derivative of x is negative, then you know that your position is moving left. Those arrows are confusing, so I'm just going to say right and left. Okay, this is for dx d theta. Now, if you were looking at dy d theta, if dy d theta is positive, then you know your position. Remember, think about the y-axis. The y-axis can move in two different directions. It's going to be up or down. So in this case, it's going to be up, okay? Similarly, if your derivative of y with respect to theta is less than 0, then you know your particle or your curve is moving down. So every derivative is slightly different. dx is not the same thing as dy. And here's the last one, dr d theta. So dr d theta really just means the radius or the pole. So let me write this one more time. If your derivative comes out positive, it's going away from the origin. Okay? Wait, hang on. Let me think about that real quick. Yes, okay. Now, dr d theta, well, let me rephrase that. dr d theta is towards or away. Would that work for all cases? Hold on, you guys. I'm thinking about this one. I'm just going to say with or against. Okay? The reason why I'm having trouble trying to phrase that there, you'll see in a second. It depends on where you are. So it's kind of relative there, okay? So we're going to come back to that one. Here's the first example. Go ahead and write it down. Everything else we'll shorthand later, okay? Okay, so some important pieces of information that you want to notice. They give you an equation in polar form. They're asking you for y theta, dy d theta, specifically at pi over 3, and then we have to analyze it, right? Okay, so we'll break this down. First thing we want to do is we want to find y theta. Okay, so remember that when you're dealing with x and y, okay, y is the same thing as r sine theta. Remember that, okay? So in this equation right here, we know what r is equal to, so I'm actually going to squeeze that in there. That's going to be something times sine theta. In this case, it's 2 sine squared theta, that's our r, times sine theta, okay? This is conveniently written enough so that we can simplify it. So y is equal to 2 sine cubed theta. And this is our y theta here. I should say y theta so that you guys don't get confused. Okay, so there's one of our answers. Boom. Okay, now if we know that y theta is equal to 2 sine cubed theta, we're going to try to find out what dy d theta is, okay? Now, before I do that, I'm going to go ahead and rewrite this so that it's a little bit easier to take the derivative. Remember that sine cubed theta is just sine theta cubed, okay? I want you guys to go ahead and find the derivative. You guys could use the prime symbol, but I'm going to stick with the same notation that they have, okay? So tell me what dy d theta is equal to. Press play whenever you're ready or if you're stuck. Okay, so here to take the derivative, notice how there is a function inside of another function here. So this requires the chain rule. So 2 is just a coefficient. We're going to take the derivative of the outside. That's 3 of something squared of the same inside times the derivative of the inside, which is cosine. Okay, so if I clean that up a little bit, dy d theta is equal to 6 sine squared theta times cosine theta. All right, so here we go. Here's another thing that we'll need to type in. All right, so then they want you to find out what y theta is and dy d theta is, specifically at pi over 3. Okay, so if we evaluate this at pi over 3, go ahead and do that. This will give you an opportunity to kind of refresh on your trig. Okay? All right, so here we go. So y here would equal 2 times sine of pi over 3 cubed. That comes out to something. I'll come back to that. Dy d theta will come out to 6 sine of pi over 3 squared times the cosine of pi over 3. Okay? Now, this is going to be 6 times something else. Okay, so you should know that the sine of pi over 3 is rad 3 over 2. Okay? If you just take a look at the unit circle, there you have it. Okay? Cosine of pi over 3 is really just 1/2. Okay? Now, you can keep going. Here they say write your answers as an exact value or round it to 3 decimal places. So we can decide to leave it here or we can decide to round it. Okay? Personally, I'm going to leave it because then that's just less work for the calculator. But there are some problems where you might want to do it. What's the whole point here, right? So the whole point here is you want to know if it ends up positive or negative. So right here, y of pi over 3 ended up with something positive because if you take a look at this here, everything is positive. So you know your overall result has to be positive as well. Same thing over here, dy d theta at pi over 3. Since all of these factors are positive, you know the overall result has to be positive as well. Okay, so what does that mean? Okay, you have a particle where the y coordinate is positive. So I'm going to draw you a picture. When the y coordinate is positive, you know it's somewhere above the x-axis. Okay? So I'm going to place a point anywhere in quadrant 1 and 2 because that's where it's above the x-axis here, right? So I'll just put a point, boom, right there. So you know where you are. The only thing left is, do you know where you're headed? Okay? You know where you're going. So since the derivative of y is positive, that implies that y is increasing, pretty much implying that it goes upwards. So you have to make a statement from that, okay? So we can say safely that the curve is moving blank, in this case, from the x-axis. Okay? So is it moving towards the x-axis or further away, right? So in this case, just by looking at our situation here, we can tell that it's moving away from the x-axis. And that's it. And how do we know that? We know that because the y position is positive and the derivative is also positive. So we know it's heading upwards, starting from an upwards position anyways. Okay? And here's the picture. Okay? At pi over 3, you're somewhere about right here. Okay? Because this is the, well, actually, you're somewhere around right, just to draw this a little bit more accurately. I got this picture from this function here, and you can graph that on your calculator. Just make sure you're in polar form, okay? But the picture is really just to kind of confirm what's happening here. You're not going to see it if you're using Desmos, because Desmos graphs it instantaneously. But if you were to graph this polar equation on your calculator, you'll actually see it animate, going in that specific direction, right? So right at the pi over 3 mark, which is about, I want to say right here, at that moment, you can tell that that point, at that moment, it's moving upwards, okay? Notice how it doesn't always move upwards, because right after it starts moving downwards. So, but more importantly, it's moving away from the x-axis here. Okay? Let's try another. Okay? Here is, should we do this? Yeah, let's jump to this one, part B. Okay? And if you want to shorthand this, you can. Just write down our equation, what they're asking for, and that's it. Okay? Press play when you're ready. So this one's a little bit different because they're asking us to find information regarding x, okay? So here we go. We know that x is equal to r cosine theta from the last lesson. And since we know what r is, that's just x equals 4 sine theta times the cosine theta. So we're pretty much substituting the r for the 4 sine theta there. All right, so our position is 4 sine theta cosine theta. All right, okay, so from there we can figure out our derivative. Okay, it might not have space, but here we go. To find the derivative, or dx d theta, this is going to require a product rule. It'll be the first 4 sine theta times the derivative of the second, which is negative sine theta. I'm running out of space here. Plus the second times the derivative of the first, which is 4 cosine theta. All right. If I clean this up here, and feel free to replay at any time, okay? This here was the product rule. So if I clean this up, I'll get negative 4 sine squared theta plus 4 cosine squared theta. Okay? So let's go ahead and evaluate this. Now that we have those two set, and Delta Math will ask you to input these, okay? They'll ask you to input this and this here. And then we're going to evaluate. So at pi over 3, we'll get 4 sine of pi over 3, cosine of pi over 3. Okay? dx d theta will equal negative 4 of sine pi over 3 squared plus 4 cosine of pi over 3 squared. Okay? Now, since we're in the first quadrant, everything comes out positive here. So just to show you, the sine of pi over 3 in this case is rad 3 over 2. And cosine is just 1/2. All of these values are positive. So you know that x of pi over 3 will come out greater than 0. Okay? Okay, now over here, it's not too obvious on what happens, but let's take a look. We have negative 4 of radical 3 over 2 squared plus 4 times 1/2 squared. Okay? To the naked eye, just looking at this, it's not too obvious on if this will come out positive or negative. So this is where you might want to use your calculator just to kind of get an idea of what it comes out to, okay? I'm going to go ahead and type this myself. Let's see, so we have radical 3 divided by 2 quantity squared plus the 4 1/2 to the second power. Okay, if you did this right, this should come out to negative 2. Okay, if you didn't get that, please do let me know. So we now know that dx d theta at pi over 3 is actually coming out less than 0. Okay, here are the second pieces of information that you'll need. So again, this tells you where you are and where you're going. And from there, you should be able to make some type of truthful statement here, okay? So here we go. I'll draw a picture for you. If you know that x is positive, okay, you're going to be somewhere over here because this is where x is positive, all right? You're not going to be over on the left side in quadrants 2 or 3 because that's where x is negative. So you're somewhere over here, so I'm just going to place a random point. Okay, so that's where you are. And since dx d theta is negative, that means that x is decreasing. So that means you're moving towards the left. Okay, so what does that imply? The implications are it's moving blank. In this case, we have to refer to the y-axis. Okay. Okay. Press play whenever you're ready. So here, since we're moving towards the left, we're moving leftwards. We know that we're going to hit the y-axis, so we're moving toward, I guess we don't need from here, the y-axis. We're not going to compare it to the x-axis because we don't have enough information about it going up or down, okay? And that's it. Okay, so there's one more example. What happens when we're dealing with the radius, right? I'm switching rooms right now, but give me 1 second. Okay, so remember, so when you're dealing with x, you're either moving left or right, right? When you have y, you're moving either up or down. And when you have r, you're moving in the direction of the pole. Okay, so here's the last one. Oh, I should show you the picture first. Hold on. So we dealt with this, and right at pi over 3, you're about right here. And in terms of the x direction, notice how it's going leftwards, right? So it makes sense that it's moving towards the y-axis, okay? And Delta Math does a really good job at that. They give you like a little slider so that you could see what happens to the values, but play along with it if you need to take a look at the solutions, okay? All right, here's the last one. Part C. Okay, so here we have r equals 2 cosine squared theta. They want us to determine what r theta is, dr d theta, and specifically both at 5 pi over 6. All right, so let's jot down what we need. We need r theta, and look at that. R theta is already given. Okay, now in Delta Math, you might have to type it as 2 cosine theta quantity squared. Okay, so with that, can we figure out what dr d theta is? Okay, this right here would have to involve what, right? Press play whenever you're ready. This here would have to involve the chain rule because here you actually have a function inside of another. So that calls for the chain rule here. So it's the derivative of the outside of the same inside times derivative of the inside. Now again, this is an opportunity for you guys to refresh your derivative rules, okay? So don't worry if you don't remember it right away. This is kind of like why we're reviewing at the same time. So if I clean this up, I get dr d theta equals -4 sine theta cosine theta, or cosine theta sine theta, okay? So here we have both. Now we're going to evaluate them at 5 pi over 6. So this is the cosine of 5 pi over 6 squared. Over here, this is -4 times sine of 5 pi over 6 times the cosine of 5 pi over 6. All right. Okay, so just by looking at this alone, I can tell that this will come out positive because when you square any value, you get something positive times a 2 gets you something even more of a positive. Okay? So some ways you could kind of analyze it to kind of skip the work a little bit. But it depends on where you are with trig. Okay? Okay, here we go. So dr d theta, this one's not super obvious, so I'll write it out. -4. Okay, sine of 5 pi over 6 is positive 1/2. Cosine of 5 pi over 6 is negative rad 3 over 2. You got to be well versed in your unit circle. Okay? If I multiply all this out, I know I'm going to end up with something positive because two negatives multiplied together will get you something positive. Okay? So here we have it. I should say this at 5 pi over 6 just to be more accurate. So what does this tell you? So here we go. When you're dealing with r, you're on the pole, okay? So here's what you do. If r theta is greater than 0, okay, you know that at 5 pi over 6, you have something positive. Do you guys remember how to plot points on the polar coordinate? Okay? So let's review it. Actually, it's not written that way. Silly Mr. Lee. All right, it's r comma theta. So r is something positive, and then the angle goes next. All right? Here's what I want you to do. I want you to plot this point here. See if we end up with matching answers there, okay? Okay, at 5 pi over 6, you're in quadrant 2. I noticed that because 5 is 1 less of 6, and that rule is in the second quadrant. That plus tells you to stay in that quadrant. If it was a negative, you would hop over to its opposite quadrant, which is quadrant 4. Okay? So if you need to review that concept, go back to notes number 1 real quick. Okay? So you're on this pole here. Okay? You're on this pole. So two things can happen. You could either go in that direction or go in that direction, right? So you're either increasing the pole or you're decreasing in the pole. All right? We know that right here, dr d theta is positive, so you know that r is increasing. So you know, in fact, it's actually moving that way. So how do you describe that, right? So you would say that the curve is moving. Now, what do you reference this to? You're going to reference it to the origin. Instead of the x and the y-axis, right, is moving blank to the origin. Okay, so in this case, it's moving away from the origin. Since you started here and r is increasing, so you're extending your radius. Okay? Now, if you were at this giant pink point and your derivative was negative, that means your r is decreasing, meaning that you would be heading towards the origin. Okay? So it's either moving towards or away from it, and what you're referencing is depending on what you're dealing with, if it's x, y, or r. Okay? Okay, so remember, it's basically this, but you have to have two pieces of information. You have to know where you are and then where you're going. Okay? Try it out on Delta Math. It takes some getting used to at first, but fill in those blanks. If you happen to get anything incorrect and you're not sure why, just let me know. Okay?